Understanding and applying the solid principles is essential for any iOS developer aiming to build clean, maintainable, and scalable apps. These principles help you write code that's easier to read, test, and extend, resulting in higher quality apps and more efficient development. In this video, we'll walk you through each solid principle with clear step-by-step examples. You'll learn how to apply them in real-world iOS projects and gain practical insights you can immediately use in your own code base. Also, make sure to check out my mentoring sessions. More on this later in the video. Now, today, this is part 2 of the solid principles series. In the previous episode, we talked about the single responsibility principle and the open-closed principle. Today, we are going to take a look at the last 3. And before we dive into it, what is basically solid? Well, it's a set of principles that you most probably want to adhere to as a programmer. It makes your life easier, makes your colleagues' life easier. And these are principles that you should, not follow by the stone. You just want to make sure that you kind of know them well. You should know them well. And write your code in a scalable manner. Okay, so we talked about the single responsibility principle and open-close principle. If you are interested in that, go ahead and check out the link in the description for the whole playlist and just select the previous one. Basically, this is the code for those. And the third one is the Liskov substitution principle. Now, this might be, really, daunting name for this principle. But basically what this does, it states subtypes must be substitutable for their base types. Level up your SwiftUI skills with personalized one-on-one mentorship. In a focused 1-hour Zoom session, you'll get expert guidance tailored to your current challenges. Whether you're stuck on a layout issue, need help structuring your app, or want to sharpen your understanding of SwiftUI best practices. Bring your questions and leave with clarity, confidence, and a clear path forward. The link is in the description. So, let's just have an example because it's quite hard to just put it into words. Let's just have, for example, a class called bird. So class called bird. And if you're not paying attention, you just, and we're going to have bad and good examples, by the way. So this is the bad example. If you're not paying attention, you might have a function called fly. And do whatever you want to do in the fly function. Okay, that looks really harmless. But what if we want to create a class? It could be penguin, by the way. But what if we had a class of ostrich? And let's adhere to the bird class. We are subclassing over here. And then we would just need to override our function, of fly. And we would just need to say, for example, fatal error with a message of ostriches cannot fly. Okay, now this is really bad because we already know that ostriches do not fly. Therefore, kind of the concept of the bird is not set up properly. So let's take a look at a better example, the good example actually. So what we need instead of creating a bird class with a fly functionality and then having subclasses of that bird, be it ostrich in our case, it could be penguin, by the way. It's also, I don't know, is it a bird? I guess not. So ostrich. So let's just create a bird protocol. So first of all, protocol. It would be a bird protocol. Bird. There we go. So that's our first protocol. And then, what I'm going to do is just comment this out. Okay. And then we know that some birds can fly and others cannot. So let's just have, I don't know, flying bird protocol. So protocol, flying bird. And that would be adhering to the bird protocol. But now we would just add an extra functionality, a func of fly over here. So whoever implements the flying bird protocol still is a bird, we are adhering to the bird protocol, but it would need to implement also the fly functionality. So if we want to, again, to create the ostrich class, so class ostrich, then we could just say it is only a bird. It's not a flying bird, it's only a bird. And other birds, we are going to adhere to the flying birds. So basically, subtypes, flying bird, must be substitutable for their base types, the bird. Hopefully that's obvious with this simple example. And now let's go on to the interface segregation principle. Okay, so what does that mean? Clients should not be forced to depend on interfaces they do not use. Now, this is kind of similar. It's basically not similar, but it kind of looks the same. So what I'm going to do is create an animal protocol. Let's just start off with a bad example. So protocol, animal. And animals, what they can do? They can fly and, and they could also run. Now, if you know these in principles, if you have a little bit of experience in coding, then you would immediately see that this is kind of an or statement. So this protocol, so animals might fly or they might run. Not all the animals that could run can fly. So it's already bad as it seems right now. And now, if you are going to use this protocol of animal, let's just call the dog. That's fine. So you just need to adhere to the protocol. So this dog needs to implement the fly functionality and the run functionality. So then, what just happened over here? Yes, we need to add that over here. So, okay, it's running. Dogs are do run, so running. But then you are just going to leave the fly functionality out, But this is extra code. This is left untouched. Maybe somebody comes over here and doesn't really understand the dog construct, and it's just going to add in here some functionality. So this is really, really bad. Instead, what you want to do is create a flyable and a runnable protocol. So let's just go down over here to the good example. So let's just have a protocol of flyable. There we go, flyable, and that would have the function of fly. And then let's just create another protocol of runnable, and it would just have that run. So now if we want to say, okay, we have a class of let's just comment this out so we can use the dog. So we have a class of dog. We don't have to implement the flyable. We are just going to say this is a runnable. And then we just need to adhere to the runnable protocol. So let's just fix this, click on over here. And then we just have to have the run, and we're just going to copy that out and paste it in there. If we are going to have a bird, I think we already have a bird. Yes. So let me just comment this out too. And I believe, yeah, no more birds. Okay. So if we are going to have a bird right over here, a class of bird that can be flyable but also runnable. Birds also can run, and then we are going to implement both of them, and then let's just print out over here like flying. Okay, so that's how it is. And also you could just have a type alias of, I don't know, birdable, but yeah, that's kind of a joke. So you want to have flyable and runnable protocol adhering. The bird should be adhered to both of them. Okay, so that's clients should not be forced to depend on interfaces they do not use. The dog right over here, well, on the bad example, is depending on the fly protocol, fly dependency that is not actually using. And finally, there is dependency inversion principle. High-level modules should not depend on low-level modules. Both should depend on abstraction. Now, again, this is kind of really, you can't actually understand it without some reference. So let's just create a bad example right over here. So we're going to create the data class of MySQL database. There we go. And then let's just have a function of save some data of string, and then do whatever you'd like. We're just going to save that string, that data to the database. Okay, now what's the problem with this? Well, actually, if we are going to use MySQL database, this is really just about saving it on one place only. Maybe we want to have a database save with other type, a NoSQL database. So let's just take a look at, let's say we want to have a data manager. If we had a data manager, then we would need to create a separate functionality for the MySQL database, a separate functionality for the NoSQL database, maybe other stuff is going on with persistence. So instead of having a class dedicated to MySQL database, we are actually going to create a protocol. I just have a protocol of database. There we go. And that will have a functionality called save data. Okay. Now we are going to add the MySQL database. It's adapter, that's fine, but we can just go with simply the database. Adapter is really fine because, the naming convention, because it's adapting the database protocol. Okay, so we are going to have the functionality of saving data, and here you are just going to, that's why we have that bad one, that's why it's having this error. So here you are just going to actually save. Now we could have another type of database. Let's just have a class of NoSQL database. There we go. And again, it would be a database. And then again, function save the data. Okay. So now that we have these two, or it could be one or even more, but now we can just create a class of data manager, and then either just pass along the database. It could be a MySQL, a NoSQL. Just say let database of type database. Of course, we do need our initializer because we are inside the class. And then we have a function called save data. And then we just say database, save data, and you just pass along the data that you are getting. So this is much, much cleaner and much more flexible. This is the dependency inversion principle. So basically what we covered in these two videos are the solid principles: single responsibility, open, close, Liskov substitution, interface segregation, and dependency inversion. Now, if you like these types of tutorials, you like my teaching style, and you have an issue inside your code, go ahead and check out my mentoring sessions. The link is down in the description. And also, this video was sponsored by Tenjin ROI One-on-One Community. Their link is down in the description.